So now moving to the 20th question, children. A man weighs 60 kg at the surface, Earth's surface. On the surface of the Earth, what is the mass of the person? 60 kgs. At what height above the Earth's surface his weight becomes 30 kg? So now you are asked, so on the surface of the Earth, the man weighs, okay, 60 kg, and you are asked to find out on the surface of the, at what height his weight becomes 30 kg. So let us look into that carefully. Children, we know the formula for F as G M1 M2 by R square. So this is the only formula known to us. Force due to gravity. Generally, F force is MA, but force due to gravity is taken as mg. This is equals to m is mass of the body. Whose mass? Man's mass. So m indicates mass of the man into gravity equals to g m. So between what two objects this force of attraction takes place? One is between the man as well as the earth. So what are the two bodies? Mass of the earth and mass of the man. If I consider mass of the earth as me and mass of the man as m, as we have already considered mass of the man as m. Okay. So mass of the earth, m1 earth's mass, m2 man's mass, m upon distance square. So sum r square. So clearly the value of g is equals to this m and m gets cancelled. Therefore, the formula for g is gm by r square. What is that? I'll be concluding this, children. So what is the formula for g? G in terms of capital G is given as G is equals to capital G m upon r square. M is the mass of the earth. M is the mass of the earth. Okay. R is the distance between the body and the surface of the earth. So this is a generalized formula. Suppose the same thing if you have considered at some certain distance G on the surface of the earth is taken as Gm by r square. Similarly, G at certain height on the surface of the earth we consider G as Gm by r square. So instead of small r, let me replace this with the capital R, because radius of the earth, let us consider it as some r square. If you go, this is the earth, children. If the body is taken at a height h, then the value of height is, so what is it? From center of the earth to this area, the radius is r, hence g equals to gm by r square. From center of the earth to the location of the body, the total distance is h plus r. That is, gh is given as gm by r plus h. Gh is given as gm by r plus h. Okay. So, at certain height, it is given as gm by r plus h whole square. So, these two formulas you need to remember, children. On the surface of the earth, acceleration due to gravity is given as gm by r square, and at certain height h above the surface of the earth, it is given as gh equals to gm by r plus h whole square. So dividing these two equations, let us see what happens. Equation 1 upon equation 2. Equation 1 upon equation 2 gives G upon GH equals to Gm by R square upon Gm by R plus H whole square. So simplifying carefully, we have this Gm and Gm gets cancelled and this R plus H whole square goes up. Then you are left with G upon GH is equals to R plus H whole square upon R square. Is that clear, children? Gm gets cancelled, R plus H carried upward and this R square. So G upon GH is R upon R plus H upon R square whole square, or G upon GH can be taken as R plus H by R square whole square. So what is that? G upon GH is equals to R plus H upon R whole square. Therefore, the value of G upon GH is equals to, taking the LCM and separating the variables, R upon R is taken as 1 plus H by R. What is the value? R by R plus H by R whole square. So separating, denominator is common for both, R for R and H for R. So R by R plus H by R whole square, or G upon GH is taken as 1 plus H by R whole square. Okay, so what is the value of G upon GH, children? It is equals to 1 plus H by R whole square, or G upon GH is equals to 1 plus, how much height, at what height above the earth's surface his weight is taken. Okay, so based on that, let us calculate H. We have to find out. In order to find out the H, what we do is, first of all, substituting, multiplying and dividing with M. So this is mg and this is a mgh. So mg indicates mass or weight of the body on the surface of the earth, and here weight of the body at a certain height h. On the surface of the earth, 60 kgs on the surface of the earth. So up you have 60 kg, and at certain height above the surface we have 30 equals to 1 plus h by r whole square. This, after simplification, you will be getting 30 goes 2 times. If 2 equals to 1 plus h by r whole square, if 2 equals to 1 plus h by r whole square, then root 2 is equals to 1 plus h by r, taking square root of both sides. 2 equals to 1 plus h by r whole square. Taking square root on both sides, square root of 2 is root 2. Square root of 1 plus h by r whole square is 1 plus h by r. So value of root 2, let us substitute as a 1.414 equals to 1 plus h by r. Or bringing this keeping the h by r here, h by r equals to 1.414 minus 1, or 0.414 equals to h by r. So this implies the value of h is equals to, what is the value of r given, children? The value of r, radius of the earth, is always 6,400 kilometers. So r times of 0.414 is 0.414 into 6,400 kilometers. Kilometers is the value of h, because options were given in kilometers. So if you multiply 0.414 with 6,400, you may approximately get it as something like 62649.4 something. So what is the value of h? The value of h is found to be, multiply this and find out, children, it will be something like 2649.4. So this happens to be the value of h. So kilometers, measured in kilometers. So we have given 4 options. The value of h here is 1624, 2424, 2624 or 2824. So it's now we got the value as 2649.6. So this value is approximately equals to 2624, and hence the correct option is option C. So approximately equals to 2624 kilometers. So children, this is a little tricky question, children. Only thing is that you have, first of all, you should be clear with the formula for G. What is the formula for G? G is equals to Gm by R square. If it is taken to a certain distance height, then R is replaced with R plus H whole square. Only the distance varies. The other values remains constant. Universal gravitational constant is constant, and M, mass of the earth, is also constant. Only variable is distance. So R plus H whole square. So if you divide both the equations, we got the relation as G by GH equals to R plus H whole square by R square. Separating the variables, then we got the G by GH as 1 plus H by R whole square, and what I did is multiplying and dividing with M. So weight of the body on the earth surface is given as 60, on at certain height is given as 30. Simplify, you'll be getting 2, 1 plus h by r whole square. Taking square root on that, you have root 2 is equals to 1 plus h by r. Root 2 is taken as 1.414 equals to 1 plus h by r. So 1 taking to the other side, then it will become 1.414 minus 1 is the value of h by r, and this is equals to 0.414. So if h by r is 0.414, h is equals to r times of 0.414, and r is given as 6,400 kilometers. Multiplying, and we will be getting the value as 2649.6 kilometers, and approximately this goes good with the second option, that is 2624 kilometers.